All right, our next topic is graphing quadratic functions using vertex form. Okay, so this is a little twist on what we did previously with our parent function and graphing our basic graphs and parabolas. Now we're going to add a little different element to it, and we're going to shift it around the graph. Okay, so that's really all we're doing when we use vertex form is we're basically just shifting that parent graph and kind of moving it around our main graph. So remember, if you recall, our parent graph, we'll use g of x equals x squared, right? That was our parent graph. That's our basic parabola, or basic graph that opens upwards. So now, what if we were to add an extra element to it and we were to shift it all on the graph? Okay, so how would we do that? So the first way we're going to shift it is we're going to add this plus k. Okay, so now we have x squared plus k. Okay, so what this means is your k here tells you if you're going to shift it up or down. Okay, and that's all we're going to do. Okay, this part stays the same. The k tells us if we're going to go up or down on our graph. Okay, so for example, let's say I were to give you the graph g of x equals x squared plus 3. Okay, so if I gave you that and we were to graph this, now this is a very simple graph, okay, then we would start at our 0, 0, right, at our base here, but then, because there's nothing changed here, but then we have this plus 3. So from our 0, 0, we're going to count up, because positive 1, 2, 3 on our y-axis, and that's going to be our new vertex, okay? So now, if we were to graph this normal graph, it would be our normal parent graph, but instead of being at 0, 0, it is now at 0, 3. Okay, so all we did was shift it up. Okay, that's all we did. So, and you can kind of see that too if we were to draw our t-tables next to each other. So if we looked at our t-table for our normal parent function, g of x equals x squared, right? And if we did our normal t-table for that, I'm not going to bore you with the math, but I'll show you if we do -2, -1, 0, 1, 2. And then we would fill that in for 1, 0, 1, 4. Remember that's our the regular t-table we use for that. Now if we compare that with our new shifted graph, okay, x equals x squared plus 3, right? So if we did the t-table for this, okay, x, y, same x's, okay, same x's, but now instead our y, basically we're gonna if we were to do the math for this, if we did x squared plus 3, so instead of x we're using -2, so -2 squared plus 3, -2 squared is 4 plus 3 is 7, so our y would be 7. Now the next one, x squared plus 3, but now it's -1 squared plus 3. So -1 squared is 1, plus 3 is 4. 4. Now you can, if you look at our parent graph, you see all we're doing with our y's for the same x is adding 3, right? So if we add 3 to 4 here, we get 7. If we add 3 to 1 here, we get 4. If we add 3 to 0, we get 3. And then back up again, add 3 to 1, 4, and then of course 7 at the end. So you see, it's the same thing as our parent graph here, it's just shifted up by 3. That's all we did for that, okay? We're just shifting the graph up 3, okay? So let's look at a different graph, okay? Let's look at g of x equals x squared minus 2. Okay, so now, if we were to look at this, now we're shifting our graph a different way. So before we shifted our graph up 3 because it was a positive 3, right? In this case, our parent graph stays the same here, okay? But instead of, when we start at 0 here, instead of going up 3, because it's a negative number, we have to count down, okay? And we count down by 2, so 1, 2. And we start our graph. Now, because our number in front here is positive, our x here is positive, so there's nothing, it still opens upward. If you remember from the last video, it still opens upward. But in this case, it starts at -2 on the y-axis, okay? So same thing, just now it's shifted down 2. Okay, and if I were to draw that, the t-table for that, x, y, -2, -1, 0, 1, 2. Okay, if we did that, our -2 squared is 4, minus 2, 4 minus 2 is 2. -1 squared is 1, minus 2 is -1. 0 squared is 0, minus 2 is -2. And then we're going to go back up again like that. Okay. So then if you were to graph, so then you can see it's still the same graph, but instead of taking it what we did for our parent function, we're just taking away 2 in this case, okay? Just a point of reference. Parent function, 4, 1, 0, 1, 4. Because we're taking away 2, we take away 2 from 4, we get 2. So on and so forth, taking away 2 from each of our y's, okay? So when you see the k here, the k at the end tells us up or down, okay? Now let's add a different element to it. So we know our k tells us up or down. Now, how do we shift it left and right, okay? So how we do that is we have our graph here, g(x) equals x minus h squared. Okay, now in this case, our h tells us which way left or right to go on the graph. So before our k at the end told us up or down, our middle one here tells us left or right. Okay, so let's say, so if we took, so if we look at our graph here, and let's say we do g of x equals x minus 2 squared. Okay. Now, the important part, this is very important to remember, is that whatever sign in the middle determines which way you go, left or right. Okay. In this case, if it's a negative number, you're going to go to the right by whatever number it is. If it's a positive here, you're going to go to the left, which is kind of the opposite of what we've been learning. But that's how it works for this here. Okay, so a negative in the middle goes right, positive in the middle goes left. So in this case, we have a -2. So if we were to graph this on our basic graph, we still start, okay, at 0, 0. Now there's nothing at the end here, so we're going to stay on the x-axis at 0. But in this case, we have a shift, and because it's negative, we're going to go right 2. So on our x-axis, starting from 0, we're going to count right 2, 1, 2, and that is our new, where our graph opens up, okay? So same thing, now it just shifted to the right, okay? So k at the end tells us up or down, h in the middle tells us left or right, all right? Along those same lines, if I gave you g of x equals x plus 5 squared, okay? Same concept, but in this case, it's our positive in the middle, and positive we go left. So still staying at 0 here, count left, 5. 1, 2, 3, 4, 5. That's our new vertex there and there, okay? So positive number in the middle, go left that many numbers on the x. Negative number in the middle, go right that many number, okay? Now, let's put it all together now, okay? So our whole formula is here. G of x equals x minus h squared plus k, okay? Now, another important thing to remember here is we need to find our vertex of our graph. Our vertex normally is xy, right? xy, that's our vertex, right? But in this case, to find out here, our vertex, our x is h, and our y is k. Okay, and I'll show that to you in a second. So let's do an example. Let's do g of x equals x minus 3 squared plus 4. Okay, so we know if we draw our simple graph here, okay, starting at 0, okay, let's shift in the middle first. So look at our middle, our h here. It's a negative, which means we go to the right, and we go to the right 3. So starting at 0, we're going to go right 1, 2, 3. Okay. Now, our k at the end is 4. It's a positive 4. So from our 3 here, we're going to go up 1, 2, 3, 4. 1, 2, 3, 4. That is our vertex. Okay. So a vertex, as we saw over here, h and k. H is 3, k is 4. Now, don't get confused by that sign in the middle. So your vertex, your x is not negative 3, okay? Remember, the minus is already there, okay? So the minus is already there. Don't even look at that, okay, in this case. If it's, the h stays by itself like that, okay? Now, let's do a quick another example here. Let's do g of x equals x plus 4 squared minus 2, okay? So in this case, draw a simple graph here. Start in the middle, okay? It's a minus, or sorry, it's a plus, which means we have to go to the left. So starting at 0, we're gonna go left 4. So 1, 2, 3, 4, okay? Oh, well, not a dot, but 4. And then we look at our k, it's negative 2. So it's negative, we have to go down 2. So 1, 2, there's our point, and there's our new graph. Okay, so our vertex number is hk. So our h is at negative 4, and our k is at negative 2. X and y, basically wherever it is on x and y. So your point, negative 4, negative 2, that's our vertex there, okay? So, quick recap of everything on vertex form. There's our vertex form formula. Okay, and actually let me rewrite this. Let me write this with an a in front, okay? Because that's also a very important part. So a times x minus h squared plus k. Now, remember, our a tells us if our parabola is opening up or down, right? So either up or down, depending if it's positive or negative, right? Positive or negative. And it tells us if it's going to be wide or narrow. Okay, so remember, if it's greater than 1, it's going to be a narrow graph, and if it's less than 1, it's going to be a wider graph, okay? Our middle term here, remember, this is going to tell us which way we go, left or right on the graph. So if it's a negative, we're going to go to the right. If it's a positive, we're going to go to the left. And our k at the end here tells us, are we going to go up or down on the y-axis, okay? So that's our last thing, up or down on the y-axis. Sorry, this marker is not super great. So that's the basic form of vertex form. That's how you can graph with this. Of course, our last one, our vertex equals hk, and our axis of symmetry equals h. So whatever we get for h, our x point and our vertex, that's also our axis of symmetry. Basically where and just to kind of reiterate that, it's where our parabola gets cut in half. So in this case, sorry, our axis of symmetry would be in the middle here, right in the middle of the graph like that, okay? So that's our basic form for vertex form. Up next, we will do standard form.